Hello, ladies and gentlemen, and welcome to our lesson 3 on long division. So you've learned how to do reverse tabular after doing the tabular. So that obviously works for dividing, and I'm going to give you an alternative method that I've been using for many years, what I learned way back when, called long division. So let's take a look. Alright, so we're going to go to our opening piece here, and basically I just got to divide 1573 by 13. So we're going to go back to 4th grade, we write the 13 on the outside. I get a little thicker here. Let's try this one. Alright, so we're going to write the 13 on the outside, and we're going to divide that into 1573. So if you remember way back when, 13 will not go into 1, okay? But 13 does go into 15 one time, so we put the 1 above. 1 times 13 is 13. And then we turn around and we subtract it. So I have a remainder of 2 out of that. Then we would bring down the next term, the 7. Well, how many times does this 13 go into 27? Well, the answer to that, obviously, is it goes twice. And then 2 times 13 is 26. We turn around, we do the opposite and subtract it, and I have a remainder of 1. Then I bring down the next term. And obviously 13 goes into 13 once, which is 13, subtract, and we have no remainder. So your answer turns out to be that 121 right here, okay? So that's what we did way back in 4th grade, and now we're going to pretty much apply that today to long division. So I'm going to show you how to do a couple of examples of that, and then we're going to practice it when we get into class. So let's go on to example 1. Alright, and so what I want to show you, we've done in cases before, is they tell you if x is equal to 10. Well, if x was 10, wouldn't that whole thing there be 13? And then this part right here, don't write any of this down, I just want to show you this. This part right here would be 10 to the 3rd power, and this part here would be plus 5 times 10 squared, plus 7 times 10, plus 3, which means 10 to the 3rd, you know, is 1,000. 5 times 10 squared, 10 squared is 100, right? So that would be 500 when you do 5 times 100. Plus 7 times 10 is 70, plus 3, and really we get the 1573 that we just did a moment ago divided by that 13 out in front, if x turned out to be 10. So I'm going to show you this in another way here. We're going to do it another way, but just so you know, we're doing the same problem, but now it's a polynomial. Alright, so how does this all work? Well, we're going to start off taking this first term that's an x, and we want to see how many times does it go into x to the 3rd. So very similar to the reverse tabular. And you know that if I take, you either say, okay, I take 1x out of the 3 of them there, and you're left with 2. Or you just divide this by an x and you take 3 minus the unwritten 1 there and you'll get 2. Either way, you need to write x squared above. Then what we do is take this x squared times x, and we get the piece right underneath here. So we know x squared times x is x cubed. And every single time you want this thing right down here to be identical to the thing there. Same sign, same exact coefficients, same exponents, same variables, identical, okay? Now, not only does the x squared have to go times the x, we got to do x squared times the 3, because there's 2 things out in front here. So what's x squared times 3? Well, obviously that's a 3x squared. And that makes sense. That's a positive 3x squared. And I put it right underneath the other x squared thing. This way they line up. Okay. We put our line underneath. And then we're going to subtract the entire thing. Okay. Well, what does that mean? Well, I like to subtract it. I like to go through and change both these signs. So what I'm going to do is I'll change color here just to show you. I change this. It's like keep, change at the adding. This guy becomes the opposite. There was no sign on it, becomes negative. This guy becomes negative. All right. So now we can, with this whole piece, line them up. What's x cubed minus x cubed? Well, it's gone. We don't need to write anything there. It's totally gone. What's 5x squared minus a 3x squared? Well, obviously that answer is 2x squared. Okay? Then, since it's nice and we're going down in descending order here, remember 3, 2, 1, and then none. So our exponents are going down. I just bring the next one down. So what's the next thing to come down in the pack? The positive 7x. Okay? So then we go back up top here. Okay? What times x goes into 2x squared? So instead of it being right there now we're down here. So x goes into 2x squared. Well, if I take one of them away from the 2, it's down to 1. And it should make sense to you. What am I left with? A 2x. So sure enough, if I multiply 2x times x, I get 2x squared. And I will write that right below. And once again, it's identical. Same signs and everything. Then I take that same 2x up here, and I multiply it times 3. Well, what is 2x times 3? Well, of course, that's 6x. So that's a plus 6x. We're going to subtract it. So I will do the same thing, keep, change, change. We're keeping the first line, by the way. This is the one we're keeping. It's like if it was written out in front, horizontally. And then I'm going to change this, and I'm going to change each of these. So I need to change those also. This becomes a negative 2x squared. This becomes a negative 6x. So then when I add them up, those guys are gone. They cancel, just like back here, they canceled. And what's 7x minus 6x? Well, that's 1x. Bring down the next term. It's a plus 3. So then we go back up top here. Okay, what times this x gives me x? Well, obviously I already have exactly what I want, so what am I multiplying by? I'm multiplying by a 1. So 1 times x is x. Take that same 1 times the 3 here, okay, and you get a positive 3. We're going to subtract the whole thing. Do your keep, change, change. So everybody changes. And I have a remainder 0. So my answer is this right up here. Okay? A little different than reverse tabular, but a pretty cool method. All right, we're going to practice one more here. All right, in example 2 here, we don't have it set up in long division, do we? No, I got the top divided by the bottom. Well, we know this from elementary school that we can go and write it. We put the 2x minus 2 out in front, put my long division bar, put a 2x cubed inside, minus a 4x squared inside. Now, if you notice, there's no x there, so you might want to put a 0x. You don't have to if you can follow it along. I'm going to put it in there, and thus I went with 3 exponent, 2 exponent, 1 exponent, and then none. So I'm ready to roll with all this. So once again, I want to know, how does 2x go into 2x cubed? Well, you notice you already got the 2, and you got one of the x's, so what's left? Yep, 2 x's are left, so I need to put an x squared in top. Then multiply it times this. So x squared times 2x is 2x cubed. We got the identical thing right here. These two babies are the same. Also, what's x squared times a minus 2? Well, that obviously is a minus 2x squared. Okay. Put in parentheses. We're going to subtract it. I'll put a line underneath it. I'll change my colors. This becomes keep, change, change. So it becomes addition, subtraction, addition this time. Okay, remember changing everything. So when I go to do this now, the 2x squared cubed and the 2x cubed cancel because 2 of them minus 2 of them gone. Okay. So those are going to cancel out. And minus 4 of the x squared and a plus 2 gives me a minus 2x squared right here. Okay, and if you're weak in all this, use a calculator to help you out. It shouldn't be at this point in your math career, but if you need it, you need it. Okay? Bring down no x's, or you're going to skip the x's. I'm going to put a plus 0x. There's just no x's there. All right, so our next thing here, once again, what times 2x gives me minus 2x squared? Well, I already have the 2. I have one of the x's, so I know I've got one left, and I got this minus sign out in front. So, obviously, I need a minus x. So, minus x times 2x gives me what I need, the minus 2x squared. It's identical. Sign and all, everything we need, okay? Then what's a minus x times 2? Well, obviously that's a minus 2x. Put my line down. Parentheses. We're going to subtract it. We're going to do keep, change, change. So this time both are minus become both plus. When I add them, these two cancel. What happens here? 0x plus 2x is 2x, right? And then I'm going to bring down the last piece, the plus 2. Okay? One more time in the step. So here we go. If I take a look at this baby right here, I have a 2x. What do I have down here? 2x, so I don't need to change anything. So that's a nice plus 1. Take the plus 1 here times the 2x, and I get 2x. Then you're going to turn around and take the 1 right here times the minus 2 and bring it down, so that's a minus 2. And Mr. O did something wrong here. I did catch it way back here. This should have been a minus 2. So let's go back and fix it. This was a minus 2 because all of a sudden I see there's a remainder and we're not ready to address that yet. So a little error. It's good to keep it in the video here. We're going to subtract the whole thing. Once again, go to keep, change them all up. Turn around, the 2x's cancel, and the 2's now cancel because that was really supposed to be a minus 2. And remainder 0, and we've got our answer right up here. Alright? So, if you don't have that, watch the video again, pieces of it, whatever it takes, and then come to class prepared with this, and we're ready to roll. See you in class.